This is going to be just a really quick look, review, or brand new learning on interval notation, because this is the way we're going to write like our domain and range for a lot of these functions. I'm going to have us do this because this is how you'll do it in college, and a lot of high school classes are moving to this as well. And it takes less writing than like a formal set builder notation. And so this is what we're going to be doing. So interval notation is a different way to write a range, so like when we're talking about inequalities. So for example, if we have, say, this inequality, let's draw us a little number line here. We'll put us a little 0. We'll put us a little 4 right there. It doesn't really matter for what I'm doing. Historically, we've put either a closed or open circle, and let's do a closed circle here, and say we shaded this black region this way, right? So historically, the way we have written this, if you've learned regular interval not interval notation, I don't even remember what it's called, standard notation, maybe, I don't even know. But then what we would write here, say this is labeled as x, right? So then we would have x is greater than or equal to 4, right? We've seen this. We've seen this in my class, and if you're just watching this on the YouTubes, you may have seen this before. So interval notation is kind of well, it depends on the problem, a simpler way to write this. It's definitely a simpler way to write it. Like if we were writing this in formal set builder notation, we would use like curly braces, and we would say it's x such that x is greater than or equal to 4. X is a member of the real numbers, right? So it's definitely what I'm about to show you is definitely shorter and less writing, less convoluted looking than this big formal set builder notation. We're about to change the way we do the closed open circle as well, so be ready for that. But the way we would write this in interval notation is we would say 4, comma, positive infinity, and then we would say it is including 4 and not including infinity, because we can never ever get to infinity, right? So this is everything from 4 including to infinity. Let's see if we can break down the pieces of this puzzle. First of all, if we want to say not including, then we use a regular parentheses. So this is not including. In these silent bits, if you hear some strange monster in the background, it's just my dog chewing on a bone over on this chair. I didn't want her to wake everybody up because I'm doing this kind of early-ish in the morning. So anyway, all that to say, yeah, that's what's happening right there. Yeah. So if I want to say including, and we just said this, we use a square bracket, right? So including is a square bracket. That'd be the closed circle, right? So this would relate to the open circle the way we've done it before, and this would relate to the closed circle the way we've done it before. Or if we're talking about 2 dimensions, this would be like the dashed line, and this would be like the solid line. We're not going into all of these details in this video. We just want to get the basics of this. So this is including. Okay. Now, we usually, when we're graphing this, we also make a slight change to the way we graph it. I'm gonna redraw this line real quick and show you what we do. So, what have I done? Drawn something crazy. It's okay. I'm gonna leave it because flavor. Do not worry about the man behind the curtain. Okay, so I might have my 0 on here and my 4 on here before. So what we change is when we graph this in interval notation, and I've actually seen professors do this both ways. I've seen them use interval notation but still use the circles, which honestly makes sense because it's just easier and clearer to see. I think if I was a college professor, that's what I would do. But the proper way to do it, there's my air quotes. There you go. Isn't that cute? The proper way to do it in integral notation is with the bracket and parentheses. And that's, we would put a square bracket here for including, and then we would shade in this direction. Right? And we would shade in our era that way, right? And so that's the correct way to do it. And if it was not including, like say we wanted to do negative infinity, because we're going this way, never including infinity, to -2, why not? And we'll say not including, then you would put -2 here, and you would do a parentheses instead of a bracket for not including, and then we would shade in this direction. All right. So real quickly, I want to get where, again, this is not meant to be everything about interval notation. This video is not. This is meant to kind of be a quick look for the purposes of what we're about to do in our next lessons. That way we can understand enough to be able to do what we need to do. So real quickly, let me look at kind of a compound inequality. So like if this was the problem, we want to write an inequality for this right here, then you have to add a symbol. I'm going to do this on a fresh page with a fresh example. Okay, so if I jump to, let's get my thing in the middle of the thing. It's hard because my screen, what I'm looking at is upside down, and so I have to use my brain. It's terrible. Okay, so if I had, let's say, I'm going to do these, I'm going to go ahead and draw this number line in black, but then I'm going to do some different colors for my interval. That way we can see it clearly. So say we had a 0 here. I almost always like to draw a 0. You don't always have to, kind of depending on where we started. If we started at 1,000,000 and then we were graphing down to negative, I don't know, 2. Well, even, I don't know. I'm kind of mumbling along here. So let's say we were given this, and we'll say including, and we'll label this as -3, and then we'll do over here and we'll say not including, that's a parentheses, and we'll say -1.5. I don't know, not the scale, not really important, not really the point of what we're doing. And then we'll have them shaded in this direction, in that direction right there, and shade our arrow because it keeps on going. And then we say, well, this was shaded this way. I almost went off into the stratosphere there. No problem. It's okay. All right. So say this was the thing, and your problem said write the interval in interval notation. All right. So we've got to include all of this and all of that. So the way, like if we were to do this in regular standard notation or whatever the heck it was called, then we would have to say, hey, the x is less than, but we would write it in a different way. We'd have to say -3 on this side. See, this is where this is why I like interval notation better, because it gets kind of confusing. X is less than or equal to -3, and it is greater than but not equal to -5. And there you go. There's that interval, right? Yeah, and you could write it, -1.5. See, it's so confusing. I forgot what in the world number I was even writing. So that would be a way to write this interval in like standard notation. And right, I don't think it's actually called standard notation, but it's escaping me what it's even called. So on this problem, in interval notation, it's actually going to take a little more writing than this, but I like it because it's pretty straightforward. Because in interval notation, we just kind of start reading from left to right. So this interval goes from negative infinity because it keeps on going, right? Well, that makes sense. And again, we can never include infinity. So infinity is always a parentheses. And then it goes all the way to -3. So comma -3. And then it's including the -3, so square bracket. Look, square bracket matches, which is one reason why the square bracket in parentheses up here is kind of nice, because it just all matches. Now, we need to find a way to say that we're talking about all of this and all of this. And so what we use this great big old U looking symbol like that. Okay? Now, this symbol stands for the word union. Okay. Right. So and what it means is we want all of this and all of this. And so then we just keep writing, right? So not including -1.5. Struggling to write that 1.5. Why did I do that to myself? And it goes all the way to positive infinity. Never including infinity. And then that's it. So when we're writing a compound interval, we end up using this union symbol. And there's a intersection symbol which looks like that, and there's some other topics and some other things involved in this topic, but for our purposes in writing domain and range of functions and things, these couple of bits, 2 or 3 things, is really all we need to know. And so that is absolutely it for this little short lesson. We will see you in the next one.